so we looked at the new fixed thread pool executor service, which basically has, like the name says, a fixed thread pool, and you can give it whatever number, and it's never going to go beyond that. If you get more runnables and it hasn't had a chance to execute whatever you already passed, those runnables have to wait. So there are a bunch of other executor services that you can use for building different kinds of thread pools, for example. So let me list out some of the other types of executor service we can use. Now, the fixed thread pool is just one of the several types. We also have something called the single-threaded executor. You can kind of think of single-threaded executor as the fixed thread pool executor, but with the thread pool size of 1. There's always going to be just one active thread. So anytime you pass it a new runnable, it is going to just wait for that one thread to be freed up, and only then it's going to execute something else. I tend to joke about this as the Node.js mode, but it's essentially just one thread, and that thread has to be freed for the next runnable to be picked up. There is the other cached thread pool executor, which provides a little more flexibility in terms of the number of thread pools. Here with the fixed thread pool executor, you have to decide upfront how many threads you want in your thread pool. But with this one, you don't decide upfront how many threads you want. So if there is a new runnable comes in, if there are available threads, it is going to reuse the threads. But if there's nothing available, it's actually going to create a new thread. There is no fixed thread pool which is binding how many threads it needs to have. It's just going to create as many as it needs, but it just doesn't do it every time. It reuses threads whenever possible, and it's going to create a new thread only when there are no threads available. And then there is a scheduled thread pool executor, which allows you to schedule a certain thread to run at a certain time. Like if you want to do it at a fixed interval, you can say I want it to run after a certain delay, and then you want it to run at a certain time after. Like let's say you can give a runnable and say I want this runnable to be executed after 3 seconds, but then after that execution is done, I want it to be repeated every 5 seconds. So you can schedule it and you can have it repeat, which is super handy. And then the fifth one is something called the work stealing thread pool executor. This is new with I believe Java 7 onwards. This requires an understanding of a concept called parallelism level, which we're not going to be tackling now. At this point, I'm going to be tackling these 4 executors. I'm going to show you what they are and how to use them, and we will tackle this one a little bit later. So we've seen how the fixed thread pool executor is this executor service which has a thread pool and it has a blocking queue for managing all the runnables that get in and which have been submitted. The cached executor service is a little bit different. Here you don't have a queue because there's really nothing that needs to wait. So in the case of a fixed thread pool executor, well, if the number of threads are all taken, and then you have more runnables, then they have to wait in a queue. But in the case of a cached executor service, the executor service is going to actually create a new thread if there are more than the number of currently running threads, right? So if there are other stuff sitting in the queue, well, it is actually going to create it. So there's no concept of this thing waiting. What it does have is this thing called a synchronous queue. A synchronous queue is essentially, it's not really a queue in that there's not going to be more than one element. It's going to be just like adding one element and removing one element in a thread safe way. And this is meant, like the design of the motivation for a synchronous queue is to kind of do a handoff of one object in a thread safe way between 2 threads. It's like one thread is saying, hey, take this thing, one thing, and the other thread is taking that thing from the other thread, all right? So it's kind of like a handoff between threads. That's the reason why the cached thread pool executor has a synchronous queue. You can think of it as a one element queue where something can be added and removed in a thread safe way. And this is where the runnable sits. And at least until the time this cached thread pool executor service has the ability to schedule it, all right? If there is an available thread, it's going to take that runnable and give it to the available thread. If there isn't one, it is going to create a new thread and then give it. So at any point of time, there's only going to be one thing which is waiting in a way. So I'm not going to go into a lot of detail about the synchronous queue, but essentially you have kind of like this handoff, and new threads are scheduled as and when needed, and threads are also removed. Thread instances are removed, so it's not like a constantly growing list of threads in the thread pool. If a certain instance is not used within 60 seconds, it's actually going to remove the thread instance. So that's the time when it actually shrinks. So it scales up to capacity and then also scales down if a certain thread instance is not being used. The scheduled thread pool executor is interesting in the sense that this also has a queue, but this is something called a delay queue. A delay queue is a special type of priority queue. A priority queue is where you have a bunch of elements in a queue, but then it's not always first in, first out. Each element has a priority in itself. It's like something is high priority, something is low priority. What decides the priority is different. But in the case of a delay queue, The priority is really the delay. You can say, I want this particular element to be executed in 2 seconds, and I want some other element, some other runnable to be executed after 5 seconds. So the after 2 seconds element has a higher priority than the after 5 seconds element. So each runnable here comes with some kind of a time specification. You might say, I want this executed after some time, or I want this executed every 5 seconds. After every execution, wait for 5 seconds and then run it again. So those are the properties of these runnables which sit in the delay queue. And then the executor service again picks up the element and then schedules it at the time that is requested. And again, there is no fixed thread pool here, because if you have a fixed thread pool, there's no guarantee that a certain element is going to run at that time. If there are no threads available, how will it run it? So there's not a fixed thread pool. It's kind of like a cached thread pool in the sense that when the time comes for a runnable to run, it'll see if there is an available thread for it to pick. If it's available, it's going to use it. If not, it's going to create a new thread, add it to the thread pool, and then use that. And then again, like the cached thread pool executor, it is going to free up threads when something hasn't been used for around like 60 seconds or something like that.